Hey ChemStars, so in this video we're going to be going over Chapter 2 practice problems, pages 10, 11, and 12. These are all density problems. So first thing, most important is you must show all your work. That means the formula, the substitution, and the answer with the correct units. It's going to be super important for this unit. Okay, so number 1, it says fill out the density triangle. Or write the density equation, whichever you normally use in your algebra class. So density is mass divided by volume, and our units will be grams per centimeter cubed. Or remember that a milliliter is the same thing as a centimeter cubed, so we also could have the units grams per milliliters. If you use the triangle to help you solve algebra equations, here it is. So density is mass over volume. If you're solving for mass, it'll be density times volume. If you're solving for volume, it'll be mass divided by density. Okay, problem number 1. The density of copper is 8.9 grams per milliliter. So I want you to underline that. We're going to label that D for density. The mass, M, is 23.5 grams. What's the volume? So V equals question mark of this sample of copper. Okay, so we're going to start with the equation first. Density equals mass over volume. And then we're going to substitute in. So 8.9 grams per milliliter is the density. The mass is 23.5 grams, and we are solving for volume. Okay, so then we want to just do our regular algebra. I'm not here to teach you the algebra. I'm here to teach you how to apply the algebra you already know. We've got to do the same things to each side to isolate and solve for volume. So volume will be mass over density. And what will that be? Take out your handy-dandy calculator of science, and we're going to take 23.5 grams, divide by 8.9 milliliters, and we're going to get 2.64. So 2.64. And my units are grams per milliliter. Don't worry about how many decimal places we have right now. We'll get to that in the next section. Okay, problem 3. An unknown metal has a mass of 12.5 grams and a volume of 5.9 centimeters cubed. What is the density? So label your variables. We're solving for density. Density is mass over volume. So let's substitute in. Here's our mass. Here's our volume. Then we just have to divide. So we're going to take 12.5 divided by 5.9, and we'll get 2.12. So 2.12 grams per centimeter cubed. Okay, now this question says, can this metal be copper? Why or why not? Well, this metal has a density of 2.12. Let's look back up here. Copper's density is 8.9. Pure substances all have the same density. So are those numbers the same? No. So why not? Well, 8.9 does not equal 2.12. This is a number much closer to aluminum or some very, very light metal. Okay, question 4. A piece of polyethylene, that's a type of foam, has a density of 0.89 grams per centimeter cubed. So there's D for density, and has a volume of 0.075 centimeters cubed. What is the mass? So start with your equation. Density is mass over volume. We know density. We don't know mass, but we do know the volume. So we've got to isolate and solve. So how do we get mass by itself? Well, we need to multiply over. Okay, so 0.89 times 0.075, 0.06675. Okay, so let's go to how many decimal places? Like 2, so 0.067. So that's a pretty light mass. Will the polyethylene float or sink in water? Well, from your notes, you know that the density of water is 1 gram per milliliter. The density of the foam is 0.89. It's less than that of water, so it will float. Why? Well, right here's your defense. If things are less dense, they will float. If they are more dense, they will sink, and 0.89 is less than 1. Okay, so there's page 10. Let's go to page 11. Here we're going to be solving things graphically. So before we start, let's just get some things written down. Density is mass over volume. Now look at this graph. We know that the slope of a line is rise over run, which is the change in y over the change in x. So here's y, here's x. Look at the slope on this graph. What are the units on my y-axis? Mass. What are the units on my x-axis? Volume. So therefore, on this graph, Oh, Ollie's barking. The slope is the density. So the slope of these two lines is density. Okay. It says determine the density of each metal. So we have two metals. We have metal A and we have metal B. And we have to go through and just find the slopes of those. So how should we do that? Hint. So where do you use the slope? Well, mass over volume. So we're going to try and find the slope graphically. And what we need to do is find two easy to read points. So for line A, I think that this point right here looks about 450. And this point looks to be about 9/100. Okay. So let's write those down and solve. So my change in Y, we're going from 50 to 100. So it's going to be 50. My change in X, we're going from 4 to 9. That's 5. So 50 divided by 5. This is 10 grams per milliliter. Okay. Now, what about, that's for metal A. What about for metal B? For metal B, we need to find two easy to read points. And so this point right here, I'm reading that as 430, and this point I'm reading as 1075. So the same thing for metal B, we've got to take the change in Y, so we're going from 30 to 75, so that's a change of about, what, 45? So we've got 45 over my change in X, we're going from 4 to 10, so 45 divided by 6. 45 divided by 6, that's about 7.5 grams per mil. That's for metal B. Now, when we're looking at this, we can see that metal B is less dense. And if you look at your graph, well, the slope isn't as steep. So the steeper the slope, the more dense the material. Okay, now from the graph, we want to estimate the mass of 8 centimeters cubed of volume of metal A. So we're going to actually go to the volume, find 8, and look at the intersection. Okay, so here's 5, 6, 7, here's 8. Looking for metal A, so we're going to kind of do a little dashed line. Ah, that looks like it's about 8. Let's come over. That looks about between 80 and 90 that I've marked off there. So let's say about 85. So about 85 grams. Now, how about the volume of 70 grams of metal B? So same thing, but now on the different axis. So 70 grams of metal B. So we're going to go over and find where 70 is. Ooh, it looks kind of, well, I'm a little bit off here. Let's go a little bit lower. Let's go straight down. That looks like we're at around 9. So approximately 9 centimeters cubed. That's how we read it off the graph. And I already marked those on the graph. Okay, now let's check our work. Let's see if these two things match up. Use the density of B, so that's this number. So density, we said, is about 7.5 grams per milliliter to determine our answer for 2B. Okay, so we have a density, we have a mass, we're solving for the volume. We're hoping we get around 9-ish. Okay, so density is mass over volume. So I know that 7.5 grams per centimeter cubed should be equal to 70 grams over my volume, and we're solving for that volume. Okay, so how do we get that algebraically? We're going to take the volume over here, multiply out. So we're taking 70 divided by 7.5. Volume equals 9.33 centimeters cubed. So that's what I got using the algebra. I read about 9 off my graph. Those numbers are pretty close. It checks out. Okay, so now relate the slopes to each metal's density. Well, the slope is equal to the density. What is the relationship between how steep the slope is and the metal's density? Well, we look back up there. The steeper the slope, the more dense the metal. So steeper slope equals denser metal. Good. You might see a question like this on a quiz or on a test, so just make sure you're comfortable reading your graphs. Okay, one more page to go in this practice. So we have some more applied density problems. Remember, before we start, let's get the equation. Density equals mass over volume, and we need to remember that 1 mil is 1 centimeter cubed by definition. Okay, so ethanol, which is a type of alcohol, just label that, see how we have the OL ending? So this is a type of alcohol. It's the same alcohol we used in the density demos. Has a density of 0.789 grams per milliliter. Label that D. what is the mass of 225 centimeters cubed of ethanol? So we're searching for mass, we know density, we know volume. So if we rearrange our algebra, we know that mass is density times volume. Let's plug in and solve. So here's my density, here's my volume. I'm multiplying these two numbers together. So 0.789 times 225, 177.525. Okay. 177.525 grams. Now the next problem, it says, or part B on question 5, what is the volume of 75 grams of ethanol? Okay, so volume, if we rearrange, is mass over density. So the mass is 75 grams. The density we're given up here is 0.789. So what is the volume of that much ethanol? So we're going to take our 75 grams, divide it by 0.789, and we get 95.06. 95.06, and my units should be centimeters cubed, or mils, that's fine. Okay, question 6. What is the density of water in grams per mil? Why? Well, it's 1. It's 1 gram per mil, or 1 gram per centimeter cubed. We've told you that as a definition. It's a pure substance. All pure water has the same density, and it is 1. Okay, question 7 is kind of like a cooking question right here. The cup is a volume widely used by cooks in the United States. 1 cup is equivalent to 225 centimeters cubed. That's a volume. If 1 cup of olive oil has a mass of 205 grams, so I'm given a mass, what's the density of olive oil in grams per centimeter cubed? So density is mass over volume. We know the mass is 205 grams. We know that the volume is 225 centimeters cubed. We're solving for density. So take 205 grams, divide by 225 centimeters cubed, and we get 0.911. So density is 0.911 grams per centimeter cubed. Okay, now let's just kind of look at that. We know that water is 1, so oil would definitely float on water. You've seen that in your everyday life. But what about if we put olive oil with ethanol? Will it sink or float? Okay, so let's go back up to ethanol. What's ethanol's density? 0.789. The less dense thing will float. So if you mix oil and ethanol, the ethanol will actually be on top of the oil. So what would you expect to happen if olive oil is poured in the container of ethanol? The olive oil will sink. It is denser than the ethanol. Okay, does this make sense with your experience with Italian salad dressing? Well, oil floats on top of water, but we know that ethanol is less dense. Okay, now our last problem here. Well, our 2 last problems. Gold has a density of 18.9 grams per centimeter cubed. A cube of gold measures 4.23 centimeters on each edge. So what's the volume? Well, volume is length times width times height. If it's a cube, those sides are all the same. So we're going to take 4.23 times 4.23 times 4.23, and we get 75.69. So 75.69, and that's going to be centimeters cubed. So that's the volume of my gold cube. Okay, what is the mass? Well, density is mass over volume. If we rearrange and solve, mass is density times volume. So let's plug in what we know. Density is 18.9 given in the problem. And the volume, whoa, hold on here, what happened? And the volume we just solved for. So the volume we're going to plug in is 75.69 centimeters cubed. Okay, so we're going to take that times 18.9, and we get 1,430.5. So 1,430.5. Wow, that's pretty heavy for a little tiny 4 centimeter cube. So gold is very dense. That means it's really, really heavy for its size. Now let's kind of extrapolate this and take the problem a little bit further. Okay, so let's say your standard backpack is 30 by 30 by 40. Suppose you find a hoard of pure gold while treasure hunting out in the wilderness. How much mass would your backpack hold if you filled it with gold? An average student has a mass of about 70 kilograms. We're going to try and compare those two values. Okay, so the first step is we need to find out what volume does your backpack hold. Your backpack is 30 by 30 by 40-ish. So we're gonna take 30 times 40, 36,000 cubic centimeters. Okay, that sounds like a lot. 36,000 cubic centimeters. Okay, so now the density of gold, we know, and we're trying to solve for the mass. So mass is density times volume. Plug in our 18.9 that we were given for density, and now we've got to plug in our volume, 36,000 centimeters cubed. Okay, so what's the mass? We're going to multiply those two together. So times 18.9, 680,400. So 680,400 grams of gold will fit in your backpack. That sounds pretty good. Now, they want to know the average student mass is in kilograms, so we should convert this number to kilograms too. So to do that, we're going to move our decimal 3 places left. So in this number, we know the decimal's implied right here. To go from grams to kilograms, it's going to be 1, 2, 3 place values left. So this is going to be 680.4 kilograms. If the average student weighs 70, this is about 10 times heavier than you. Do you think you can carry 10 times your body weight in gold? I don't know, might be worth trying. Okay, so that's the end of our density problems. If you have any questions, just make sure you check with your teacher, show all your work, show all your units, and don't wait to be great. Bye, guys.